Okay, well, now for the part two, I'm going to talk about meteor showers, a little bit of an intro on how to view them, a little bit of history, where they came from, and also what I do. This is my passion. I love everything about astronomy. Love getting out with my telescope that I just presented. But many nights, what I prefer is to leave the telescopes at home, just go out with my lawn chair, my sleeping bag, my accessory kit, and that's it. That's all I need. And I'll drive hours with that, only that, because this is what I really enjoy. So a little bit about me. So what I do, there's my typical setup. And a while back, I had I had built this along with a friend who helped me, this box. And we was known as the Meteor coffin. So what it is, basically just added protection against the wind, against the cold. I could put like a little heater in that box. And if I'm out, a lot of the meteor showers, the good meteor activity tends to be in the late part of the year or during the cold weather. So that would help to keep me warm. And more recent times, I've been basically I stopped using the coffin, the box, because it's a lot of wood, a lot of pieces to bring out and set up. And I simplified by using basically a baby sack, waterproof, water resistant, over my sleeping bag. So that keeps me dry and works pretty good. So my passion on meteor showers started at a very young age. I was about 12 or 13 years old. And as you can see, I was already taking all kinds of meticulous notes, all written in French here. But I was really captivated by all this stuff, and I wanted to try to record and to note everything that I saw in details. And there's a picture of my very first serious camera that I also used to take night shots back in the film days.
Here, you've got a no builds effect box on your screen there. It's blocking the screen a little bit. It says no build effects.
Okay, I don't think I see it.
Okay.
No,
it's the lower right-hand corner.
No, unfortunately, with presentation mode, I don't. Let me just
okay.
Let me just do this, and
it's right there below your dissolve tab on the right-hand side there. Yeah, just keep going down. Yeah, just to the right. Yeah, right there.
Okay, perfect. So let me just go back, and hopefully this is this better?
Yeah, that's much better. Thank you.
Okay, super. So now, why do I do this? Like, why do I enjoy going out and driving hours to dark sky sites so much? Well, right now, I'm going to shut up, and I'm just going to let you soak in this view. This is one of my pictures from a site about an hour's drive outside of Ottawa. And what I love is experience the sight, the sounds of nature. So yeah, I'm going to shut up and just listen and take on the view a little bit. So how nice is that? You know, I never get tired of listening to the spring sounds, the animals, the crickets, the spring peepers. It's to me, that's the whole experience, being out there in nature, and of course, you know, taking on the meteor show that happens overhead. So I also love to capture meteors on cameras, and there's a composite image on the left side of the Quadrantids from a few years ago, and one of the brighter Quadrantids on the right side. And I enjoyed the challenge. It's a little bit like fishing. When you're out with the camera, you don't know where the meteors will go by. The meteors can happen very randomly in any part of the sky, and the shooting stars will last less than a second. So the best thing to do is set up the camera with a wide-angle lens aimed up, in the sky, more than halfway up, and then start with a remote control for your trigger, start taking a continuous 30-second exposures with your settings up at the, as high as the sky will allow. Ideally, ISO 1600 with wide angle lens that can open up to maybe f2.8 or more if it's possible. And this will give you the best chance to capture those fleeting shooting stars that we can see. And I also really enjoy anything that's involves transient sky phenomena, not just meteors, but also solar eclipses. And these are some of my recent images from the 2017 eclipse. It was my very first experience seeing totality. And it's something that really gets to you. It's unbelievable. It's no pictures can really give you the feeling of experiencing this live. When you see the sky darken, the temperature drops, the animals start to act in bizarre ways. And then the corona around the sun, it's just unbelievable when you see this with your eyes. Now back to meteors, a little bit of a history on meteors. They've been observed for hundreds, thousands of years, and there's a lot of literature that we were able to find about them. Particularly the 1492 meteorite impact was interpreted as a sign from the gods. There was no real understanding of what those things were. And later on, meteors were then thought to be atmospheric weather phenomena. So there's something that was happening in the atmosphere, sort of like electrical discharge or something of the sort, which had nothing to do with the stars or space. And it was obviously poorly understood because it's such a fleeting object. It flashes across the sky for a second at most, and then it's gone. So how do you study those things? So scientists also didn't believe in meteorites. Meteorite is the part of the shooting star that survives the atmosphere re-entry and might fall on the ground as a chunk of a fragment of rock. So it wasn't until the 1800s that they actually thought that could be possible. So one thing happened in 1833 that changed all of this. It was a major meteor display where the sky filled up with thousands of shooting stars, totally surprised people all over North America, and woke them up, and people were panicking in the streets, thinking it was the end of the world, that the sun wouldn't come up. And it was very obvious that the sheer quantity of meteors were coming down from one single point in the sky. And that point in the sky was moving along with the stars. So it was a fixed point with the stars. And that was the first confirmation to the scientists that meteor showers are not an atmospheric phenomena, but they have a cosmic, an astronomical origin. And this was the beginning of modern meteor science with this amazing meteor display that occurred. So now, since the 1833 Leonids, we've learned a lot about meteor science, what they are and where they come from. There's been huge advances in the science. So just in a nutshell here, when we're talking about the meteor, basically meteor is the shooting star or falling star. It's that brief flash of light that you see crossing the sky, which can be beautiful, looks like a firework. When it's a meteoroid, it's the particle of dust or rock that's still in space, that hasn't reached the atmosphere yet. Meteorite would be what you see on the left side, the three chunks. This is any fragments that are large enough to survive the atmospheric re-entry, burn up and break up into pieces and might reach the ground as surviving rocks. And then the asteroid and comets. Well, meteor showers, where do they come from? They come from larger bodies in the solar system. The asteroid is, they basically would be considered like a very, very large meteoroid. And the comets are more brittle, more almost like an icy mountain, a dirty icy mountain would be a good description. And as the comet approaches the sun, it'll start to release gases and dust and then form the tail, the beautiful tail that you see in pictures. For the most part, the mass majority of the shooting stars and meteors that we see in the sky actually come from comets. And a small fraction may come from an asteroid breakup or a collision, something of the sort could cause those fragments. Okay, so now those meteors, we know that the majority of meteors that we see, they happen in the upper atmosphere, well above 90 kilometers in altitude. So even if you see a nice bright one, it looks like it might be very close, but in reality, it's dozens of kilometers up in the atmosphere. Often we have the illusion that meteors are closer than what they actually are. Now the fireballs, the ones that are caused by larger chunks of space debris, those can come down in the atmosphere quite a bit lower, down to the 40 kilometers in some cases. And if they're massive enough, if it's a big enough chunk, then it could survive, it could drop meteorites onto the surface. Now, when we see a big meteor, like a fireball, like ones that penetrate deep in the atmosphere, they will often produce an afterglow in the sky, which looks like a column of smoke or like a bright line afterglow in the sky. And what this is basically the energy. There's so much energy when those meteors hit the atmosphere. It's the speeds are about or in the dozens of kilometers per second. It's a lot of energy, even for a tiny particle about the size of my fingertip. It will produce a bright visible meteor in the sky. And the larger pieces, what happens is that there's enough energy to create this afterglow, which is a column of ionized air molecules in the atmosphere. And you can see this afterglow from anywhere from a few seconds and up to several minutes in some cases. And you'll notice they do take different shapes, and they'll drift across the sky and gradually fade away. And those are caused by the high atmosphere winds. Okay, they occur, again, very high in the atmosphere. And then you have the second type, which is the smoke trail, most often seen in the daylight fireballs, then at night. And here's a view of the Russian fireball several years ago. I'll talk about this a little bit later, but this is a good example. It was a piece of a small asteroid that entered the atmosphere deep enough to produce this smoke trail of debris, and then produced a huge number of meteorites and sonic booms and enough energy that it broke several windows and triggered a lot of people to panic because they did not understand what was going on. And those can look like an aircraft contrail. So here's one of my pictures of a bright Quadrantid meteor. And you'll notice I'm going to play it back, see if it works. And there's the persistent train. So you see that orange train drifting. I'll just play it again for you to see. So to the eye, I could see it for several seconds. And on the pictures, with the sensitivity, the extra sensitivity of the camera, could capture it over several minutes. And I was able to produce this time lapse. Now here's that famous Russian meteor from 2013 in the wintertime that entered. There's probably one of my favorite videos because it shows the entire length of the fireball and just how bright this thing got. The sun was just coming up, and look how bright it was. It was a chunk of asteroid a few meters wide. So definitely the most significant event that occurred in the past few years. Really spectacular. And here's the sound of the sonic boom. I'll just move it forward a little bit because this video goes on. And we should hear it shortly. Yeah, so that was that was a big event. So you can see why people were freaking out when that happened. The sonic boom is basically the meteor broke up in several pieces, and each individual fragment produced its own sonic boom. So that's the reason why in the sound you hear the loud shock wave at first, and then you hear multiple booms from all these fragments that are just coming down towards the surface. Fortunately, no one was, apart from the damage that the broken windows caused, and I think there was a few people hurt. There was no casualties. All the meteorites fell into unpopulated areas, and the biggest chunk went right into the middle of the frozen lake. So the astronomers were then using simple triangulation method. There was so many of these webcams and dash cams and videos that captured this fireball that they were able to piece all these images together, and with triangulation, figure out exactly where the most probable areas of meteorite fell on the surface of the Earth. So the yellow path that you see on the map is the trajectory of the fireball with the multiple flares that it produced. And right below, it's a little bit small. You might have a hard time seeing it on your computers. But the wide oval circle was a very large number of small fragments. And as you look ahead, just below the yellow line, there's several red dots scattered all over the place. Those are the larger chunks that were recovered. And then you keep going all the way to the left side, towards the middle left side, you'll find one little red dot in the middle of the lake, which was the largest fragment that fell. So there was tons of recovered meteorites from this event, which allowed us to learn a lot about this asteroid that it certainly does not happen often. It's the estimate, I believe, about a once in a 50 or so year occurrence. And when that happens, typically it would happen above the ocean where nobody would ever see it, ever know about it. And in this case, we were fortunate enough that it happened where a lot of data was available to piece the parts together. So now I'm going to talk a little bit about meteor showers, which you may have heard or you may have seen the Perseids in the middle of August, in mid-August when you're out camping or at the cottage, and you're able to see an increase in the numbers of shooting stars that are visible in the sky. Now the meteors, notice that they appear to come from a single point in the sky, just like that image of the Leonids I was showing earlier, where all the meteors were coming down, and it was really coming down like almost like rain, but obviously the meteors don't go down to the surface, they stay in the sky. But the irradiance effect is simply a perspective effect where the meteors enter the atmosphere more or less in parallel paths. And as for the point of view of the observer, so on the example on the right side, there's no actual screen. This is just an exaggerated view for clarity. But for from the point of view of someone on a planet looking at the shower, would see the meteors diverging from a single point. So the ones that are moving out of the radiant would be the meteors that seem to be coming almost head on towards the observer, as opposed to the meteors that are further away and will be passing sideways to the person. A little bit like if you're standing on a bridge, you're looking down and you're seeing all the lines of the wood, the bridge diverging out. And when we get those meteor showers, why do we see the Perseids every August and the Geminids every December? Well, what happens is those meteor showers are created by comets that shed a dust of stream along its orbit. And after a number of orbits, the comet released more and more dust that spread all over the orbit. And every year when the Earth passes at the same point in time, roughly the same time, day and hour, there's a sharp rise in meteors, and we get what's known as a meteor shower. So just simply an increase in the numbers of the shooting stars that we see in the sky. There's several meteor showers, about a dozen of what's known as the annual, the major showers, different strengths. And the meteor showers are beautiful to see, but they're also very important for study. Helps us learn more about the solar system, in particular the comets that created those particles. And studying meteor showers also helps us predict when the next big meteor storm, like the 1833 Leonids, might occur. Because when that happens, then we have to think about all those satellites and spacecraft that are in orbit that may need to be protected, may need to be reoriented so that they are not hit by any dust particles that would damage. You know, just a small dust particle could damage a satellite. And it has occurred in the 90s during the Perseids, just a regular meteor shower. That satellite in orbit was unlucky, very unlucky. It got hit by a Perseid about the size of my fingernail, and it wiped out the satellite. It was toast, no good. So knowing when that's going to happen can help the satellite operators prepare, which is important. And also if there's something very big coming our way, like a major asteroid, then it helps also to know if there's any potential near Earth asteroid. So there's a list of the different showers active. Now, I won't go through this in detail, but the one that's the most popular is the August Perseid. And there's a few of these showers that are also not annual. Most of them are annual showers, but then some of them are spectacular, will only be seen a few times in your lifetime if you are lucky enough to see it. And of course, there are many, many more minor showers that this list does not show. So on any given night, even if you're not looking at the sky during these dates, you will see meteors that are not associated with any showers, that are known as sporadic activity. So they can happen randomly in any part of the sky, any time of the year. And there's always a few of these visible each hour. Okay, so the meteor showers, different ones are unique for a different reason. You have some that produce more bright meteors than others. And also the two of the big ones every year is the Degenerates in December and the Perseids in the middle of August. So now quickly going to go through the year's best meteor showers, starting with the one that's active in a few nights from now, the Aquarius. It's one of two of the showers that are actually created by the famous comet Halley. So this one is a bit hard to see because it's only visible for a short time, a couple of hours before dawn. It's mostly a shower that's more easily seen in the southern hemisphere. But the few meteors that we can see here can tend to be very long streaks across the sky because they happen as the radiant, the part of the sky that you see on the right side on the sky map. That part of the sky is always very low, even at dawn. And so the meteors seem to graze the upper atmosphere and they trace long, long paths, which seeing even one or two of these can be well worth your effort. And this year, the moon will be in the sky, low in the sky. So when it comes to meteor showers, if the moon is up, you will not see as well the meteor activity. It really helps to focus on those meteor showers where the moon is away, where it's as close as possible to new moon. Now the Midsommar meteor complex is one of my favorite times of the year to view in late July. That's the time where after a few months of relatively low activity, we start to see more and more shooting stars. And the Delta Aquarius is the main shower out of many, many that are active at this period of the year. And as with the case of most meteor showers, you tend to see more of them after midnight. So sometimes it's worth going to bed early and then you get up late at night and you make the effort to go out and you'll be rewarded. You'll be seeing a lot more than you would in the early evening hours. And this year it's going to be pretty good for this one. And then everyone's favorite is the Perseids in the middle of August. So this year the moon will be rising the last quarter. So it will suffer, the shower will suffer a little bit for visibility, but there's possibly going to be a higher concentration of dust that might give a better than average view of the Perseids towards the early morning hours. Now, very quickly, what is this ZHR? It refers to the number of meteors that you might see if you're on a very dark country sky, well away from the city lights, and you were looking at optimal conditions when right at the peak of the shower with an open, clear sky, and also the radiant, the part of the sky where the meteors come from, is directly overhead. Most of the time, that won't happen because you'll have not as good sky conditions, and you're more likely going to see less than half of that number. So the Perseids tend to produce pretty bright meteors. And a cool fact is that in 2028, there could be a very strong outburst. So even though the Perseids are pretty reliable, every year, every August 12, we can see up to about 1 meteor per minute in a dark sky. Every few years, we get closer to a higher concentration of dust. And that can give rise to possibly 300 or more meteors per hour on that night in 2028. So we have a little ways to wait, but it's something to keep in mind. In October, the Orionis is the other comet Halley shower. And this one is a moderate activity. It's about 20-25 meteors per hour. But every once in a while, every 12 years or so, they do tend to produce more activity and a higher increase in bright meteors. And possibly this might happen this year or for the next couple of years, but we won't know for sure until we're actually looking at it. So one thing with watching meteors and those predictions is that there's no guarantees, unlike planetary phenomena or solar eclipses, where we can predict them down to the very second. When it comes to meteors, it's not perfect. There's too much that we still don't know about where the dust is located in space, simply because we cannot see it. So the best way that they use to predict meteor shower activity is using computer models. So when the comet goes around the sun, they try to figure out where all that dust is going based on the gravity effects of the planet and based on the sun's, the solar wind that's acting up on those dust particles. It's all going to push things in different ways. And that's how they can sort of get an idea of when we can expect to see potentially a better meteor display. And a cool fact is, as you see on the pictures on the slide, 2006, 2007 were very good years for the Orionis. It was actually a very, nearly as good as the Perseids would be. So hopefully that's going to happen again this year. Now, the Leonids is the famous shower that I explained earlier, the historic 1833 shower. It still exists. It's visible every year in very small numbers, and only very occasionally will become spectacular. These are the fastest meteors among all the showers, hitting in the atmosphere at 71 kilometers per second. That's a lot. That's very fast. It's like here to Montreal in, what, about a second or two. One prediction from a model shows that there could be a few upticks in activity just before 2 o'clock in the morning and just after 3 o'clock in the morning. So something to keep an eye on. And we have excellent viewing conditions, new moon, so that says it all. And then a cool fact is, apart from the historical 1833 storm, there were several other years where thousands of meteors from this shower were visible every hour in a short time. The next big storm is not expected until 2094. So we got a long way to wait. And then the Degenerate meteor shower, this is my personal favorite, the most reliable and prolific of the showers. And it's been increasing gradually every year. It's now producing a little over 2 meteors per minute at the maximum. And it happens in the cold part of the year, so there's not as many people who tend to watch this one compared to the Perseids. Weather can be an issue also, but if you get a chance to see it, I highly recommend it. There's also enough bright meteors that you'll see a lot even in the suburbs. You don't really have to go to a dark place, even though driving out to the countryside will always give you the best view of a meteor shower. And yeah, so the Geminids are also visible in good numbers, even as early as mid-evening. And then the best rates happen just after midnight. And then there's this little known late December meteor shower just before Christmas. That's every year produces only a very small number of meteors, but occasionally can be spectacular. And this is one of those years where it may be very, very strong for a reason that there's knots of higher concentration of dust in the orbit of the stream that could give rise to very strong rates. And when that could happen is in the early morning hours, just after 2 o'clock in the morning, and then again in the evening at about 10 o'clock. And there could be, so there's another filament predicted just after 1 o'clock in the morning. So this could be something to keep an eye on. So circle this shower on your calendar. And right now, there's not a whole lot of information about what might happen, but I'm sure we'll know more in the coming months. So now when I go out, this is typically, a lot of the stuff I'll bring with me to make the experience more comfortable. And one of the cool things about meteor observing is that you do not need to have a telescope or any optical aid. Your eyes alone are the best tool for viewing and being comfortable. Lawn chair, sleeping bag, a good pillow, and then, snacks. Definitely you want mosquito spray if you're in the summertime. And all of this will make the experience more comfortable. And this is an old illustration I did from many years ago. There was a site I went to, and there were actually cows in the field that would approach me if I would have the misfortune of bringing a box of donuts. Now, a little bit about light pollution. There's one of the challenge is to get to a dark spot. Now, this is a bit of a depressing view because it shows just how bad light pollution has become. Now, you see Ottawa, Montreal are huge. Even between Ottawa and Montreal, where there used to be pretty nice dark skies about 20 years ago, now it's been affected severely. So if you go to a place like near Castleman or Moose Creek, you'll look to the west, you'll see the glow of Ottawa in that direction. And if you look out east, you'll easily see Montreal. And if you, looking at this map, this satellite image with the data of the light pollution, to get to a place that's dark enough to show what our ancestors saw 100 years ago, you need to get to the gray areas on this map. So you have to drive a long way out past Renfrew, out past Pembroke, into Algonquin Park there, into that circular area. Or this, there's a dark sky pocket that's southwest of Renfrew. That's also quite good. But even from that location, you notice it's not completely black. If you look towards Ottawa or you look down towards Kingston, and you have your camera, you'll take pictures of the horizon, you'll notice there's going to be light domes. There's going to be light pollution. So now, as I mentioned earlier, getting out to dark skies really enhances the meteor experience by a long shot. You'll see so much more if you see a lot of stars up in the sky. Now, the recommendation is, if you can't travel 2 or 3 hours out, try to get at least into the light green area, sort of like, north of Renfrew, or you won't escape the light pollution completely, but you'll reduce it enough that you can see the Milky Way quite well, and you'll see a lot more meteors. And even failing that, a 20 minutes drive outside of the city will make a big difference compared to Orleans or Canada in the suburbs, where the light pollution is really, really bad. Now, as for public dark sites, a few recommendations, and here's my disclaimer. Here's a warning, is that do not go to these places right now because of COVID. They are closed. Okay, but in normal times, if you wanted to get a really good view in a public site, there's what's called the North Frontenac Dark Sky Preserve. So the municipality there created this area in a dark area with washrooms, a parking lot, a nice concrete pad that you can set up your telescope or your chair and have a really good view of the sky in an area that's very, very dark. And it's really well done. Would recommend it. It's about a 2-hour drive, so it's a little bit far, but It's if you get a chance to see it, it's really good. And a little further out than that, there's also the Lennox and Eddington dark sky viewing area, which is very handy, not just for Ottawa, but for Kingston, for people living in Kingston and Napanee and even Toronto. This is the most south, it's known to be the most southerly dark sky site in Ontario. And it's pretty good. It's just off the Highway 41. And another option is to join an astronomy club or group like the RASC, the OAOG, or the Ottawa Astronomy Friends. And when you join, they will provide you with pointers for access to dark observing sites that are private near Ottawa, many of which are closer distance than the ones that are shown here. But here, once again, please don't go to these sites right now because of COVID. They are closed. And a little bit about the weather. Just wanted to mention this website, cleardarksky.com, known as the Clear Sky Chart. This is a very handy tool for weather forecasting. If you want to know if the sky is going to be clear the next couple of nights, take a look at this. At a glance, you can see whatever is blue squares, it shows clear, and white is the clouds. And where down the line there's black, there's no squares, is because the data hasn't been refreshed on the Clear Sky Chart. So what this does is it feeds, Attila Denko is the one who manages this, who created this product, which is really, really great. And what it does is it feeds, it goes into the Canadian Meteorological Center's database of weather modeling and forecasting and gets the data, and then it brings it up into this handy little tool here. And if you move your mouse on the square and you click, it will open up the map, an actual map showing where the clouds are around you. So really handy to see at a glance when it's going to be clear. Highly recommend this product. Now, just to finish up, because I think I'm getting well into our break now. So just a few handy resources for meteors. If you want to read more, learn more, there's some good magazines and resources. Website, spaceweather.com. Take a look, a really good little site that will give you up-to-date news about what's going on up in the sky. And you get a handy little current solar view for the sunspots and any relevant news happening. This is a NASA sponsored site that gives you a quick rundown of what's going on. And then this Meteor News is also a good online resource to know specifically about meteor showers, what's been happening and what's going on. So Meteor News, I would recommend as well. And that wraps up the presentation. I'll check if there's questions. But
there are some questions.
Okay.
So first question is, as an amateur, do you sometimes get to work with scientists on meteors?
Okay, that's a very good question, and it does happen on a regular basis where the scientists, the professionals, will actively ask the amateurs for help, because what happens is that they don't have the time to get out in the field, drive hours into a dark sky site, and stand out in the dark to record meteor activity. So they rely on amateurs to contribute data. And that data that when I take my voice notes when I'm out watching, the next day I'll send that out to the International Meteor Organization. They collect the data from amateurs, and then the pros, the researchers, can go and gather the data and then do some more detailed analysis. So yes, there's definitely a lot of collaboration all the time.
Okay, thank you. Next one is from Sue. Would it be possible to put this presentation on your website, or is there a calendar with these meteor shower dates shown?
Yeah, that would be a terrific idea to make the presentation available on one of our websites. I completely agree. And I would recommend, if you look online, there's definitely a guide. I would suggest probably easiest is type in 2020 meteor showers, and it'll bring up one of the, I think it's the Sky News webpage, where it shows at a glance the different meteor activity that's active. And check out also the American Meteor Society. They have a calendar of the year's activity, the meteor showers, and you'll be able to get the details there too.
Okay, thank you. And from Peter, are there filters that can be used to minimize light pollution for wide-angle sky photos?
For wide-angle sky photos, not so much for meteors, because in case of the meteors, you'll definitely be attenuating the light. So that wouldn't work as well. If you're doing regular astrophotography with a lens, capturing the Milky Way or other sky objects, then yes, there are definitely filters on the market that'll reduce light pollution. There's what's known as broadband filters that will somewhat reduce the worst of the light pollution or the sky glow. And then the narrowband filters, which will cut down even more and allow you to specifically get clearer view or images of nebula and other objects that are affected this way. But for meteors, unfortunately, there's not an easy solution. The best way is to get out under a dark sky. Or if you're limited, you can also just simply reduce your exposure time or bump up the F ratio of your lens so that the image is not washed out as quickly.
Okay, thank you very much. That's all the questions. So if you can stop sharing, I'll bring up my screen and we'll review the schedule for tonight. Thank you very much, Pierre.
Thank you very much.